Hi, welcome to our video. Today we are working in our geometry assignment. We are asked to choose a structure or building to study. According to the instruction, we need to pick a structure or building and explain its geometry function. After some decision, we decide to focus on the building method from Block 1 at the Faculty of Science and Mathematics or FSM. This is our chosen geometry structure, the FSM signboard that marked Block 1. Let's go and explore it in more detail. This signboard is placed right at the entrance of Block 1 Faculty of Science and Mathematics. It serves as a landmark that is easily seen by the student, staff, visitors when they arrive at the faculty. The main function of this structure is a multimaker. It helps people to identify the location of FSM easily and represent the identity of the faculty. It is not used for any special location. It serves as the permanent sign of the building. In terms of size, the signboard stands about 2 meters tall and around 1.8 meters wide at the base. Although it is not very large, it is clear and noticeable, fulfilling its role as a marker effectively. Now we are introduced to the structure. Let's continue and explore the geometrical shape and pattern found in the signboard.
So, for the part B, the geometry, I'll be explaining about all the geometrical shapes found in the object. Let's take a look at this signboard for Block 1. At first glance, we will notice the main shape is a rectangle. And we also can observe the other two rectangles in the signboard. First, a rectangle is a quadrilateral, which means it has 4 sides. Second is a type of a parallelogram, where all the angles are right angles, which is 90 degrees. Third, in a rectangle, the opposite sides are not only parallel but also equal in length. Although the front is a rectangle, the entire signboard is actually a cuboid. So, what's a cuboid? A cuboid is a 3D solid shape made up of 6 rectangular faces. The length, width, and height of the cuboid can be different, which gives it depth and volume. The next shape is a trapezoid. A trapezoid is a quadrilateral, which means it has 4 sides. But what makes it special is that it's exactly 2 parallel sides. These 2 parallel sides are called the bases. The other 2 sides are called the legs, and they are not always equal. But when they are equal, we call it an isosceles trapezoid. In an isosceles trapezoid, the 2 legs are congruent. That means they are the same length and the angles at each end of the bases are also equal. Now, let's move on to our next shape, the pentagon. A pentagon is a polygon with 5 sides, but not all pentagons looks the same. In this case, we are looking at an irregular pentagon. So what does that mean? An irregular pentagon has 5 sides that are not all equal in length. Its angles can also be different, not all the same like in a regular pentagon. Next, a hexagon is a polygon with 6 sides. But just like a pentagon, not all hexagons look the same. Today, we are focusing on an irregular hexagon. An irregular hexagon has 6 sides that are not equal in length. The angles are also not all the same. The next shape is rhombus. A rhombus is a type of a parallelogram. That means its opposite sides are parallel. But here is what makes it special. It has 2 congruent adjacent sides, and in fact, all 4 sides are equal in length. That's why a rhombus is also a quadrilateral, because it has 4 sides, and in the case, all of them are equal in length. Its opposite angles are also equal. Other than that, we also have kite. A kite is a type of quadrilateral, which means it has 4 sides. But here is what makes it more special. A kite has 2 distinct pairs of congruent adjacent sides. That means the sides next to each other are the same length, but the 2 pairs are not same as each other. The kite also usually has 1 pair of opposite angles that are equal. Next shape is a circle. A circle is the set of all points in a plane that are at fixed distance from a central point. That fixed distance is called the radius, and the point of the center is called the center. Last but not least, we found a triangle here. An isosceles triangle has 2 congruent sides. That means 2 sides are exactly the same length. These 2 equal sides are called the legs. while the third side is called the base. The angles opposite the equal sides are also equal. So that's all from me. Thank you.
Good day everyone. Today I will be presenting on the topic of geometrical concepts, specifically using the design elements found on the signage of Block 1 at UPSI. Through this presentation, I will demonstrate the relationships between geometric shapes and their measurements such as perimeter, area, volume, and angles based on what we have learned in class. First, pentagon. This first shape we identify is a pentagon, which is a closed two-dimensional polygon with 5 sides and 5 angles. There are two types of pentagons, which is regular, where all sides and angles are equal, and irregular, which they differ. On the signage, the pentagon is irregular. It has two slanted sides of 9.5 cm, two horizontal sides of 12.5 cm, and a left side of 10.5 cm. To calculate the perimeter, we add all 5 sides together. And after calculate, we got that the perimeter is 54.5 cm. Next, we observe a hexagon, which has 6 sides and 6 angles. Like the pentagon, this one is also irregular. The measurements are 2 top sides of 6.5 cm, 2 middle sides of 3.5 cm, and 2 bottom sides of 5.5 cm. As calculated, the perimeter is 31 cm. A rhombus is a special type of parallelogram where all 4 sides are equal. On the signage, each side measures 7.5 cm. So, the perimeter, we can use the formula of 4a, which equal to 4 times the side. After calculate, we got that the perimeter is 30 cm. Now, to calculate area, we use its diagonal d1, which is equal to 8 cm, and d2 equal to 12.7 cm. And the formula for the area is a equal to half times d1 times d2, and we find that the area of the rhombus is 50.8 cm square. Next, a kite is a quadrilateral with 2 pairs of adjacent equal sides and perpendicular diagonals. This kite has 2 longer sides of 7.5 cm and 2 shorter sides of 3.5 cm. And to get the perimeter, we add all the lengths together, and the perimeter is 22 cm. Now, by using diagonals d1 equal to 5.6 cm and diagonal to 13.92 cm, we can calculate the area. And after substitute all together, we got that the area is 38.98 cm square. Here we have an isosceles triangle where 2 sides are equal. So these 2 sides are 9 cm and the base is 13.5 cm. For the perimeter, we add all together and we got that the perimeter of the triangle is 31.5 cm. With a height of 6 cm, area equal to half times base times height, and after calculate, we got that the area is 40.5 cm square. Now, using trigonometry, we find the base angles. Cos theta equal to 6.75 over 9, and the base angle, we got that theta equal to 41.41 degree. So the top angle, as we know, the sum of these 3 angles are 180 degrees. So the top angle is 180 degree minus by these 2 base angles, and we got that 97.18 degree as the top angle. Now, circle. A circle is a round shape with all boundary points equidistant from the center. The signage circle has a diameter of 13 cm. So the radius is 13 divided by 2, so we got 6.5 cm. So for the circumference, pi times 13 and equal to 40.84 cm. And for the area, after calculate, the area of the circle is 132.73 cm square. A trapezoid has 1 pair of parallel sides. This shape has legs of 80 cm and top base of 50 cm and a bottom base of 135 cm. So we can calculate the perimeter by sum all these lines together, and we got the perimeter of the trapezoid is 350 cm. Given the height is 77.46 cm, so we can calculate the area. After we do the counting, the area is 7,366.7 cm square. Moving on, cuboid. The cuboid is a 3-dimensional figure with 6 rectangular faces. Its dimensions are length equal to 300 cm, width 17 cm, height 78 cm. So to calculate surface area as the given formula, After we calculate, we get that the surface area is equal to 40,652 centimeters squared. So the volume 200 times 17 times 78. So the volume is equal to 265,200 centimeter cube. Lastly, we have a rectangle, a two-dimensional shape with opposite sides, equal and 4 right angles. The length is 33 centimeter, the width is 15 centimeter. And for the perimeter, after calculate, we have the perimeter is 96 centimeter, and for the area, after substitute into the formula, we have the area is 495 centimeters squared. So that's all. Thank you.
Now, we will look at the transformation in motifs. First, what is motif? Motif is a distinctive element that is repeated. It can be a shape, or a color, or even a word in literature. Now, we will look at the motif that we found on the structure. The motif that we found on the structure is triangles, pentagons, and hexagon. And the transformation that exists there is translation, rotation, and reflection. The first transformation is translation. This is the motif of translation. The triangle is called translation because the triangle is shifted horizontally to create a row. So that is why it's called translation, transformation. Second is reflection. This is the motif of reflection. This is pentagon. This pentagon called reflection at vertical axis. And last one is rotation. This is motif of the rotation. Hexagon rotated at the central point. This is what we call rotation. Next, we will look at the transformation in patterns. First, let's take a look about what is pattern. Pattern is an arrangement or a design that created by a repeated of the motif. It can be repeating in a predictable way or a less predictable way. And the pattern found on the structure is repeating row, mirror symmetry, and radial symmetry. First is repeating row. Repeating row produced by translating the moving shape without rotating it or flipping it. Next is mirror symmetry pattern. Mirror symmetry pattern produced by reflection, which is flipping a shape over a line like a mirror. And last one is radial symmetry pattern. Radial symmetry pattern produced by rotation that rotate a shape around a central point and it looks like a flower. This is a pattern of a repeating row. A triangle motifs are repeated in a straight horizontal line. This is mirror symmetry pattern. The pentagon and the other motif nearby are reflected over a vertical axis. This is radial symmetry pattern. A hexagon is rotated repeatedly and form a circular pattern. Next, I will proceed to the summary of our study. Our main goal was to explore how specific geometrical shapes are applied in real life. To do this, we use various measuring tools like measure tape, ruler, and others to help us to identify and to calculate dimensions accurately. And then, we found several shapes, including trapezoids, rhombus, kites, and rectangle. And these shapes were not only present visually, but they also reflected real geometric principles like sides, angles, and symmetry. We also discovered that all the transformations we have learned at class, like translation, reflection, and rotation, this helped reinforce our understandings about the transformation that we learned in our syllabus. And from our findings, we concluded that visual learning methods like observing shapes, observing perimeters, areas and volumes of the geometrical shapes help us connect theory with practice and show us how mathematical concepts are applied in everyday structures, and it made learning more interesting. And next, beyond the classroom, these concepts have many real-life applications. For example, in architecture and engineering, transformations are used to design symmetrical structures, scale building components, and ensure efficient spatial planning. Besides, in computer graphics and animation, they are essential for moving, rotating, and resizing objects within digital environments. Overall, the study not only strengthened our gaps of mathematical theory, but also highlighted the practical value of calculations and transformations in solving real-life and technical challenges.